G'day guys, Mr. Bennett here. Today we're going to look at an alternative method of doing first principles. Now this particular case is a little bit quicker probably than using the limit as h goes to x. The only problem with this one is it only works out the solution for a particular point. But anyway, let's just go through the different methods for that. So the definition is here, shown here, f dash of a as the limit as x goes to a, f of x take f of a all over x take a. Now the key thing here is what we'll be looking for is to get rid of the bottom line with what's on the top line. So it makes our rearrangement of the function a little bit easier because we already know what the top line should work out to be. So let's do this one over here. So the first thing we should do is work out what f of 3 is. So that's going to be 3 squared plus 3 times by 3, take 4, so it's 9 plus 9, 18, take 4 is going to give us 14. That's right. Okay, so let's just let's get straight into it. So we're looking to find the limit as x equals 3, so that's going to be the limit as x goes to 3, 3. I'll get rid of that. Alright, so then all we're doing is going to write f of x, that's going to be x squared plus 3x take 4, and then that's going to be take 14. Alright, and then on the bottom line is going to be simply x take a, which is x take 3. So what we're looking for in the top line is to get an x take 3. So we're going to simplify this, a little bit the same process what we did before. We're going to expand out anything on the top line, but really don't have to expand because it's already in that form. We just have to combine these two things there, so it's going to be x take plus 3x take 18, and that's all over x take 3. Now, if you understand how this works, this next step is really easy. All right? We have to factorise that. And I know some of you probably still have trouble with factorisation. The thing here is, if you understand this, you don't really need to better factorise. I'm looking from the top line, x take 3. That's what I know, because I have to cancel that out with the bottom line, so then I can actually, I can take the limit. So to get x squared, I have to times that by x. To get 18, negative 18, I have to times that by plus 6. Now, if you FOIL that out, you will find you'll get that answer there. So you don't really even have to know FOIL to actually be able to do this. You can cancel that out there. Now I'm in a situation where I can take the limit. So therefore, f dashed of 3 is going to be equal to simply 3 plus 6, which is equal to 9. That's my answer. Okay, so pretty simple, right? And you have the choice of doing it this way or using a limit as h goes to 0 for these techniques. So, alright, let's go down and do another one very quickly for you. We'll do all of these in one go today, so rather than watching 3 different videos. Alright, so let's say we had this one here. Alright, so the first thing I'll need to do, I might work in red. F dashed of 7 is going to be equal to 7 plus 2, the square root of that, which is going to give me 9, that's going to give me 3. Right, so if we do this, f dashed of x equals simply the limit as x goes to 7 of x plus 2 take 3 all over x take 7. Now, not dissimilar to the first thing, when we have surds in there, what we need to do is we need to times by the conjugate. So we're going to times by the conjugate in this particular case. It's simply what's on the top line, but you change that sign to be positive. Okay, so instead of having 2 surds, we've got 1 surd here. That'll be over 3. Remember, you just can't times by that, you have to times by 1. So I have to put that on the bottom line as well. Okay, so that'll be plus 3. Right, so when we FOIL that top line out now, what we'll get is simply the limit as x goes to 7 of simply x plus 2, because that will be those two sets times together take 9, and then that will be all over x take 7, and you can't forget the bottom line, that's going to be x plus 2 plus 3. Alright, so I think you can see quite obviously what's going to happen on the top line is you're going to get what's on the bottom line. Alright, so that's going to give us x plus 2 take 9, which is going to be x take 7. That's going to be x take 7. And then I've got this thing in the bottom line, x plus 2 plus 3. Having trouble with my pen. Alright, so in this particular case here, we are able to cancel out. And this is taking the limit as x goes to 7. So at this particular stage, we can say, therefore, f dashed of 7 is going to be equal to 1 all over 7 plus 2 plus 3, which is going to give me an answer of, well, 7 plus 2 is 9, square root of 9 is going to be 3, 3 plus 3 is 6, so that's going to give me an answer of 186. So simply the same sort of ideas as what we've been doing before. Alright, so again now the third type of question that we saw before was to do something with a fraction. Alright, so again we have to find f of negative 2. f of negative 2 is going to be 1 over 2 times by negative 2, take 1. So that's going to give me negative 4 take 1 is negative 1/5. Okay, so same process again, f dashed of, was it negative 2? So get rid of that. F dashed of negative 2 is going to be equal to the limit as x goes to negative 2, f of x, which is simply going to be 1 over 2x take 1, take f of negative 2, which is going to be take negative 1/5, so that's going to be plus 1/5. And then over here it's going to be x take negative 2, which will be x plus 2. Alright, so what did we do before when we had a fraction? We did a cross multiplication, but everything over a common denominator, lowest common denominator. Alright, so that's what we're going to do here, and we don't simplify the bottom line as usual. If we do that, we're making work for ourselves. So if we think of the lowest common denominator, you're going to get obviously 2x take 1, and we're going to have 5. Okay, so that's what we've got on the bottom line there. Now multiplying there, that will go across there, so that will become, and that will go up to there, so it'll be 5 plus 2x take 1. So it works out quite simply. The next step is to collect that, and keeping in mind we're looking for, on the bottom line, we're looking for something that's got an x plus 2 in it. Okay, that's what we're looking for in every case, because we need to be able to cancel that out. So as x goes to negative 2, so that will become 2x plus 4 all over 2 over x plus 2, and then we've got 2x take 1 times 5. Can you see there's common factor 2 in there? Yes, we can do that. So that's equal to the limit as x goes to 2. Now bring common factor 2, x plus 2 there. We've got our x plus 2 here. Right, so 2x take 1 times 5. Now we can cancel out our 2x plus 2, and then we can take our limit as x goes to negative 2. I've left the negative 2 off there. Make sure you don't do that, because that's poor mathematical reasoning, isn't it? So that will become 2 all over, we've got all the lines that didn't work before. So 2 times by 2, negative 2, take 1, and it's going to be times by 5, so that's going to give me 2 all over negative 5 times 5 is negative 25. Okay, so this is an alternative method to using f as the limit as h goes to 0. The only problem with this method is it only works for one particular case. So if you want to work out what the limit is for different values, then you have to actually do this process again for each value. But it is a little bit quicker and probably easier if you know you have to work it only at one point. So good luck with those questions when you get to do them. I think probably be worthwhile knowing both methods, so then you can have that choice which way you want to go and do that. So good luck with them, and I'll talk to you in class.